What's up, fam? This is Coach Knight again, ready to take on a new lesson today. Today we're going to talk about the amplitude and period of sine and cosine. And basically this is just another lesson where we're talking about graphing sine function and cosine function and what the different parts of the equation do to the graph. So we're focusing in on amplitude and period, and if you've forgotten or don't know, your amplitude is how far the wavelength goes up or down from the midline. Your amplitude is always positive number because it is a distance, and the period is how many degrees your equation goes through before it starts over again. So here's the equation for sine. Here's the equation for cosine. If you notice, they're exactly the same. It's just one is sine and one is cosine. The A stands for amplitude. And your period you get by saying 2 pi divided by whatever K is. So your amplitude is A. It's very easy to find. You can just look at it. For the period, though, you have to plug in to this little 2 pi over K formula. That will give you your period. So we got a few examples here, 4 of them to be exact. The directions just say state the amplitude and period for each function, then graph the function. So the amplitude, like I said, it's the easiest. It's just whatever number is in front of your sine or cosine. So in this case, the amplitude is 3. To get your period, we are going to say 2 pi divided by K. In this case, K is 1. It's an understood number in front of that theta. So 2 pi divided by 1 is just 2 pi. And then it says to graph the function. So I'm going to graph it right here. And I'm just going to go 2 wavelengths. I don't like how not straight that line is, so let me try that one again. It's a little better. Now, if we're here for the other lesson, remember we talked about I always break the period down into fourths. That just makes it easy. And so since I'm doing 2 periods worth, that actually means I'm going to break it down into 8. So there's 2. That would be 4. And then half that again, and then we have 8. And so how do you know what to count by? Well, you take your period. In this case, it's 2 pi over 1, which was 2 pi, and you divide it into fourths. So in this case, we're going to be going by pi over 2 every time. So this one will be pi over 2. 2 pi over 2 is pi. 3 pi over 2. 4 pi over 2 is 2 pi. 5 pi over 2. 6 pi over 2 is 3 pi. 7 pi over 2. And 8 pi over 2 is 4 pi. And we're dealing with sine, and hopefully you remember with sine, when you're going through the pi's, it crosses the x-axis. So here's my y-axis, here's my x-axis. So here is all you do. You go through, it's going to go through at 0. Sine always starts at 0. Cosine will start up here at 1 or -1, depending on the equation. Oh, I forgot to label something on here. My amplitude is how high or low it goes, so this will be labeled 3 and -3. And that just means we're going up 3 or down to -3, and that's as far as we're going to go. So back to labeling our points. So we'll have a point at 0, 1 at pi, 2 pi, 3 pi, 4 pi, and then after an even pi, it will be a maximum. So up here at 3, after an odd pi, it's a minimum. So, and basically that pattern just continues. You go up, down, up, down, up, down. And then you draw your graph. And so as you can tell, one full wavelength takes 2 pi to get through one full wavelength. So that's one period. I graphed 2 periods worth of the graph. Amplitude is 3. So moving on, go to the next one. Amplitude is 5/2. Notice, not -5/2, it's +5/2 because, again, amplitude is a distance, and distance is always measured in positives. So my period will be 2 pi over k. And again, for this problem, 2 pi k is 2. K theta. So 2 pi over 2 equals pi. So we go to graph it again. Draw as straight as I can. And the great thing about these is the graph doesn't change. The graph is the same pretty much every time. The only thing that changes is where you put the graph and what you label. What do you label the intervals? So again, we're going to do two periods worth. So that's 8 total intervals. And again, how do you know what to count by? Well, you take your period, which is right here, pi, and you divide it into fourths. So pi divided by 4 is pi over 4. So we're going to count by pi over 4. So pi over 4, 2 pi over 4 would be pi over 2. 3 pi over 4, 4 pi over 4 is pi. That's 1 period worth. 5 pi over 4, 6 pi over 4 reduces to 3 pi over 2. 7 pi over 4. And then finally 8 pi over 4 is 2 pi. So again, we're going through 2 periods worth, growing, and if you didn't understand, I reduced my fraction as I went. This is actually pi over 4, as I've already got written. Pi over 4, 2 pi over 4 reduces, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and 8 pi over 4. I just reduce the highlighted ones here. Okay? And those reduce to pi over 2, pi, 3 pi over 2, and 2 pi. And then it's just remembering where you start and where you go. So this is a cosine. And if you remember, cosine starts at either the maximum or the minimum. Now, what's my maximum and minimum here? Well, what was my amplitude? It's 5/2. So 5/2, -5/2. It's going to go up to 5/2 and down to -5/2. Now, normally, we start at the positive 5/2 up here because cosine, if you remember, you don't start at the origin, you start at the maximum or the minimum for cosine. For sine, you start at the origin, like we did right here. It was the origin because it was sine. Cosine, you start at either the max or the min. Now, it's pretty simple to know where to start. If this number right here is negative, then you start at the bottom. If it's positive, then you start at the top. It's very simple. And again, you just follow the pattern. So from the bottom, you can't go any further down. So you go up where you're crossing the x-axis to the maximum, x-axis again, minimum, x-axis again, maximum, x-axis again, minimum. And then you draw your graph. Oh, messed that one up bad. Let's see if I can start from this way. Yeah, that's a little easier. And there's your wavelength. Again, the wavelength really hasn't changed. we're just labeling it different. Okay, the graph is the same as it has been. All right, number 3, amplitude is 1/3. Period will be 2 pi over, what is k for this one? It is 3. So 2 pi over 3. So this one's a little more challenging because 2 pi over 3, when we go to graph that, that's not so easy. Let's try this again. There we go. So there's our x and y axes. Again, we're going to do 2 pi or 2 periods worth. So I'll break it up into 8 sections, and basically I just half it into 8 parts. And this time we're going by 2 pi over 3 is 1 period worth. So what have I been saying? You take your period, you divide it by 4, and that will tell you what you label your intervals to be. So 2 pi over 3 divided by 4 is 2 pi over 12, which reduces to pi over 6. So this time we're counting by pi over 6s. So this is pi over 6. I'm going to bring it down here. The next one would be 2 pi over 6, which reduces to pi over 3. The next one is 3 pi over 6, which reduces to pi over 2. And finally we get 4 pi over 6, which reduces to 3 pi over 2. That is 1 period. But we're going to do 2 periods worth, so I'm going to keep going. So the next one would be 5 pi over 6, which doesn't reduce, so I just write 5 pi over 6. 6 pi over 6 reduces to just pi. 7 pi over 6 does not reduce. And then 8 pi over 6 reduces to 4 pi over 3. And that will be 2 periods worth. So this time we're at sine. Sine always starts at the origin. Now, do we go up or do we go down? I keep forgetting to label this. How far are we going up? Well, what is my amplitude? My amplitude is 1/3 down to -1/3. So again, how do you know whether to go up first or down first? You look at this little sign that's in front of the problem. So it's -1/3. So that means we go down first. So we'll go down to a minimum, x-intercept, maximum, x-intercept, minimum, x-intercept, maximum, x-intercept, done. And then you just play everybody's favorite childhood game, connect the dots. Done. All right, last one of this type. Amplitude, 3.7. Period. One we have to do a little finagling with, 2 pi over k. So that's 2 pi over 4 pi over 5. Good gracious, that's ugly. So we're dividing by a fraction. So because 4 pi over k, or 4 pi over 5, excuse me, is my k. So I'm going to flip it and multiply. And that will be 10 over 4. The pi's actually cancel. Everything down here cancels. So I'm left with 10 over 4, which reduces to 5 halves. So we will be counting for this problem to 5 halves. 5 halves is 1 period. And again, just like on the rest of them, we're going to break it up into 8 parts because again I want to do 2 periods worth. So I know 1 period will be 5 over 2 long, and I know 2 periods would be, well, that'd be 10 over 2, which is 5. So those are there. How do I know what to count by? Same thing we've been doing. We're going to take our period, divide it by 4. That's 5 over 8. So we're actually going to count by 5 over 8s. So this would be 5 over 8. The next one would be 10 over 8. 5 over 8 plus 5 over 8 would be 10 over 8, and that reduces to 5/4. The next one would be 15 over 8. Does that reduce? I don't think it does. So we just leave it 15 over 8. The next one would be 20 over 8, which, believe it or not, reduces to 5/2. That's the way we want it to. All right, if we added 5 more 8s to that, that would be 25 over 8, which does not reduce. Then we have 30 over 8, which does reduce. Let's see here, that'd be 4 will go in, nope, 4 won't go into 30. 2 will go into 30 15 times, and 2 will go into 8/4, so 15/4. 35 over 8 does not reduce. And then finally, 40 over 8 equals 5. So again, that's how you get your intervals. Then the graph, you use your rules. We're doing cosine. Cosine starts at the maximum or the minimum, which, by the way, the maximum would be 3.7. The minimum is negative 3.7. And since it's cosine, I'm going to start, notice 3.7 is a positive 3.7, so we'll start at the top, and then you just follow the pattern. So maximum, x-intercept, minimum, x-intercept, maximum, x-intercept, minimum, x-intercept, maximum. And you draw your curve. Ooh, that one was bad. Much better. Okay, so there's the graphing part. You may also have problems that look like this. There's 4 more. These are a little quicker because you don't have to graph them. All they're asking you to do basically is to write the equation. So they give you everything you need to write the equation. They give you the amplitude and the period, and you just have to write the equation. So the amplitude is very simple. They want us to do a sine and a cosine function. So if it says sine, you write sine. If it says cosine, you write cosine. They want us to do both. So we're going to have y equals, my amplitude is 10. Now, the amplitude is 10, but in the equation, it could be positive or negative 10. So you have to put both of them because you don't know which one they want, okay? It's positive or negative 10. I know the amplitude is always positive, but in the equation, the number can be negative. You saw that in number 3 up here where we did, and number 2. They were both negatives. The number was, okay? So you have to put plus or minus, and the first one we'll let it be sine. And then we have to figure out what k is, because k theta, if I go back up to the top, remember it's a times sine of k theta or a times cosine of k theta. So I need to know what k is. Well, how do I figure out what k is? Well, I set my period equal to 2 pi over k, and I solve this. Basically, you just cross multiply. That'll be 4k equals 2 pi, and you divide by 4. And so k equals pi over 2. And then you write your equation. Oops, I just did the wrong problem. Sorry about that. Let's start over again over here. Try this one more time. That's 2 pi over k. Cross multiply those. That will be 4 pi times k equals 2 pi. Divide by 4 pi. And we get k equals 1 over 2. So it's 1/2 theta. And then to do cosine, it's the same thing. Y equals plus or minus 10 cosine of 1/2 theta. Very, very simple. Here we go again. We know it's going to be y equals plus or minus, in this case, for number 6, the amplitude is 1/5. Don't know why I put 2 there. 1/5 times the sine. Again, we have to figure out what k is. So that equals 2 pi over k. You cross multiply those, you get pi times k equals 6 pi. Excuse me. If you divide by pi, k equals 6. So 6 theta. And that is all you have to do. To do cosine, you do the same thing. Same thing. Two more. Amplitude here is plus or minus 6. Sine of, we got to figure out what k is. So again, we've already did this one. 2 pi over k. If you cross multiply that, that's 4k equals 2 pi. Divide by 4. K will be pi over 2. So that's pi over 2 times theta. Plus or minus 6 cosine of pi over 2 times theta. And again, most of the time when you have problems like these, they don't ask for both the sine and the cosine function. They're just going to ask for one. I'm just showing you how to do it for both. It's the same thing. You just change one to sine and one to cosine. Last one, y equals plus or minus. The amplitude is 2/7. Sine of, we got to figure out what k is. So set this equal to 2 pi over k. Cross multiply, that's 0.7 pi. K equals 2 pi. You divide by 0.7 pi. You get k equals 2 over 0.7. To be honest, 2 divided by 0.7 is, if you change that to a fraction, is 20 over 7. I don't really like putting decimals in my fractions. So 20 over 7 theta. Very simple. Last but not least, you do the cosine, write the same exact thing, but it's cosine of 20 over 7 theta. So hopefully these problems give you a little help on how to do them, the ones you're trying to do. We'll sign off here. Hope you have a good night.